This is Spring Theory, the Mousetrap car concepts on string wraps and wheel circumference, because distance matters and mousetrap cars do not grow on trees. Hi, I'm Dawn DeWitt, and this is Charles Tharp. We have many years' experience with mousetrap cars, and in a series of lessons, we will provide you with detailed information about every aspect of mousetrap cars to help you design the best mousetrap car for your needs. This Spring Theory lesson will focus on a couple of the variables that affect the distance the mousetrap car can travel, including the number of string wraps and the circumference of the drive wheels. Attention will be paid to calculations that allow for making predictions about the distance of travel, so get your calculator ready. Why are you interested in mousetrap cars? Is it for some type of school project or competition? You'll need to answer a few questions about the goals for your mousetrap car project. There's likely requirements that need to be met for you to get the best grade or the highest score. Check those out, since they should drive the decisions that you make for the design and components you select. Can the distance a mousetrap car travels be predicted? The answer? Yes, it can. Before you go to the effort of building a mousetrap car, do what an engineer does. Design for a certain outcome. Most of the mousetrap car designs that you've probably seen rely on the number of times the string wraps around the drive wheel axle to determine the distance of travel. When the string is wrapped around the axle and then pulled off, the stored potential energy in the spring is released. It causes the axle around which the string is wrapped to turn that specific number of times. That translates into a linear distance as the wheel attached to the axle also turns. You'll need to know a few things about the wheels you've chosen to predict the distance the mousetrap car will travel. Since a wheel is a geometric figure, a circle, we can measure it. What things can you measure about a circle? Several things can be measured on a circle. They are circumference, diameter, and radius. Circumference C of a circle is the distance around the edge of the circle as if it were opened up and straightened out into a line. Remember, diameter D is a measure all the way across the circle, passing through the center of the circle, and radius R is the distance from the center of the circle to anywhere along the circle. If you know either diameter or radius, you can find the other, because 1/2 D equals R, or D equals 2R. Determine the radius of the circle by dividing D by 2, or the diameter by multiplying R times 2. The formula for calculating circumference is C equals pi D, or C equals 2 pi R. Many of the mousetrap cars you've seen use CDs for wheels. This is a great use for old CDs. They're perfectly round and they can be easily attached to an axle with precision. Let's calculate the circumference of a CD. A standard CD has a diameter of 12 centimeters. What is the radius? Remember, R equals 1/2 D, or D divided by 2. So 12 centimeters divided by 2 equals a radius of 6 centimeters. Since the formula for circumference is C equals 2 pi R, or C equals pi D, and the common value for pi is 3.14, for the CD wheels we would multiply 2 times 3.14 times R. So it's 2 times 3.14 equals 6.28, and 6.28 times 6 centimeters equals 37.68, or 37.7 centimeters rounded. For C equals pi D, that would be 3.14 times 12 equals 37.68, or 37.7 centimeters rounded. Remember that string in the mousetrap car? Let's see if we can tie the idea of string wraps and circumference together to see how it relates to being able to predict the distance a mousetrap car can travel. In a Mousetrap car with CD wheels, if the string is wrapped around the axle one time and it turns the axle with the CD wheel on it, it will produce a distance traveled of approximately 37.7 centimeters, because 1 times 37.7 equals 37.7 centimeters. There are other factors such as mass of the car or friction that contribute to more or less distance, but for now, let's assume there are no other conditions affecting the distance of travel. Does the Mousetrap car have only one string wrap around the axle? No, of course not. How many wraps then? How will you know? Well, you can count them. The distance of travel can be predicted by multiplying the number of string wraps by the wheel circumference. So with one string wrap, the car will travel 37.7 centimeters. With 2, 75.4. With 10, 377 centimeters. In a controlled experiment, we can make predictions. Here, the number of string wraps was manipulated while the circumference of the wheel was held constant. The resulting effect is the distance of travel produced by the different number of string wraps. We can hypothesize that if there are more string wraps, then the Mousetrap car will travel farther. Can you just make the string longer so the car will travel farther? Sorry, it's not that simple. The bail on the Mousetrap is only so long and it can only pull so much string. If you make the string longer, the extra string wraps won't do any pulling, and it sometimes can make your car stop its forward motion and even go in reverse. To get more string wraps, the Mousetrap bail arm can be lengthened. You've probably seen Mousetrap cars like this. The longer bail requires a longer string that can be pulled over a greater distance. This simple form of gearing results in more turns of the wheel and a greater distance of travel. Lengthening the bail makes the whole car longer and more massive, which can affect the performance of your car. Without an extended bail, you'll get 8 to 10 string wraps on a 1/8 inch or a 0.3 centimeter diameter axle. With that same string length, an axle with smaller diameter will produce more wraps than a larger axle, and more wraps means more distance. What is your purpose for building a Mousetrap car? Do you want it to go far? Do you want it to go fast? Or both? In all likelihood, distance matters either way. So why not use a larger wheel? We can use math to predict the effect the wheel circumference has on distance. Distance equals wheel circumference times the number of string wraps, or D equals C times W. In this scenario, the independent variable is the wheel circumference, and the number of string wraps is held constant. The dependent variable or outcome is the distance the Mousetrap car travels. We can hypothesize. If the wheels are larger, then the Mousetrap car will travel farther. A larger wheel makes the Mousetrap car go farther and slower in one rotation than a smaller wheel. So 10 string wraps will get you farther with a larger wheel. Conversely, a smaller wheel will not go as far, having a smaller circumference, so you'll need more turns of a smaller wheel to go as far as a large wheel. But it can produce greater speed since it will turn faster. Manipulating this variable will make the car longer or shorter and more or less massive, all of which can affect the performance of your Mousetrap car. In this spring theory lesson, the Mousetrap car on string wraps and wheel circumference, we've shown you how to determine the role of wheel circumference in the performance of a Mousetrap car and how to manipulate circumference to make the car go different distances by using different size wheels. We've also shown you how to use calculations of circumference and the number of string wraps to make a distance prediction with the formula distance equals circumference times the number of wraps, or D equals C times W. This illustrates that you can determine the performance of a Mousetrap car by making predictions using math before you build. Work like an engineer, use math, and be deliberate in the components that you select to create your Mousetrap car, because it matters. There are many variables that affect the performance of the Mousetrap car, and there are trade-offs that you make with each option that you choose. Manipulating the number of string wraps and deliberately selecting the wheels for their circumference can improve the results. Gears can also be used to improve the distance of travel and the speed, but those are topics for another lesson. This has been Spring Theory, the Mousetrap car concepts on string wraps and wheel circumference. We hope you found this information useful enough to save to watch again later and to share with your friends. Be sure to like our video and subscribe to our channel so you will have direct access to new Spring Theory content. Until next time, because Mousetrap cars do not grow on trees.